Hello, and welcome to this Math Bay video on law of sines. I'm going to do this in 3 parts. The first part is going to be deriving law of sines and using it for some simple examples. The second part is going to be using the law of sines to solve what I call a tree on a hill problem. And then the third part is going to be looking at law of sines in terms of the ambiguous case for angle side side. So let's get on with the first part. The law of sines is going to be derived from using area with sine, which we previously explored. If you start with the area with sine with 1/2 BC sine A and 1/2 AC sine B and 1/2 AB sine C, and you take this seemingly three-sided equation, you divide all three sides by 1/2 ABC, because an equation can be divided on both sides by the same value, or in this case, all three sides, you end up with a lot of canceling going on. In this one, the 1/2 and the B and the C cancel out. You're left with sine A over A. In the middle one, the 1/2 and the A and the C cancel out. You're left with sine B over B. And then in the final one, you're left with 1/2 sine C over C. Oh, I'm sorry, just sine C over C. So this is an equation saying that in any triangle, not just a right triangle, the sine of an angle over its opposite side remains a constant ratio for that entire triangle. So let's use this to solve a few problems. In triangle ABC, A, side A, little a, is 16. The measure of angle A is 40, and the measure of angle B is 58. In law of sines, you have the sine of an angle over its opposite side equals the sine of an angle over its opposite side. So taking two at a time, I can just use it as a proportion, these two, or the first and the third. So it really doesn't matter if it's A or B or C and which one we're dealing with. We just know that sine of 40 over its opposite side is going to equal sine of 58 over its opposite side, which we're calling lowercase b. So cross multiply gives me 16 sine of 58 equals b sine of 40, which leaves me with, if I divide both sides by sine 40, b is equal to 16 sine 58 over sine of 40. So now I will take the calculator and work this out. I will do 16 sine 58. See what I get when I do that. Oops, 58. That gives me about 13.6. Now I will divide it by the sine of 40. Be sure to check those calculators are in degree mode. And I get the unknown side is about 21.1. So B is approximately 21.1, which should make sense. Basic triangle inequality says that in a triangle, the larger side is opposite the larger angle, and you can see B is larger than 16. So that kind of makes sense, as we would hope that it would. Got a couple more examples here. In triangle ABC, A is 80, that's a big number. B is 60. The measure of angle A is 52. We are asked to find the measure of angle B. So this time, we are going to use law of sines to find an unknown angle rather than an unknown side. So we know the angle of 52 and its opposite side of 80. So sine of 52 over 80 equals sine of angle B over its opposite side of 60. So cross multiply, 60 sine 52 equals 80 sine of B. Divide both sides by 80. We know the sine of B is equal to 60 sine 52 over 80. So let's see what happens when we work this out in our calculator. 60 sine of 52 is a little over 47. I'm going to divide that by 80, and I get 0.59101. I'm going to go to 4 places. So the sine of B is approximately 0.591 008, so 0.5910. Now we have to remember, this is the sine of B. It is not the measure of angle B. So in order to get the measure of angle B, I have to use my inverse trigonometric function, switching the input and output. So I will ask the calculator, given the sine ratio, tell me the angle which has that ratio. And I get about 36.157, or about 36.2 degrees. So the measure of angle B, about 36.2 degrees. Checking my reasonableness on that. Well, 60 is opposite a smaller angle with that 36.2 degrees, and 52 is opposite a larger angle. So our inequality rules for triangles hold. Okay, 2 more examples, and then we'll kind of summarize a little bit about when we can use law of sines and when we cannot. In triangle ABC, B is 18, the side opposite angle B. The measure of angle A is 64, and the measure of angle C is 55. We are asked to find side C to the nearest tenth. Okay, so again, don't think I'm actually going to solve this one because it's very, very similar to the other one that we just did. Sine 55 over C and sine 60. Oh, it's not very similar to the other one we just did. I know I can do sine 55 over C. I guess I did design this problem the way that I meant to. But if I've got this side to work with, I kind of need this angle. So at first glance, you might think we can't use law of sines to do it. However, we can. Don't forget that the 3 angles of a triangle add up to 180. So if I take 180 degrees and I subtract 55 and I subtract 64, I'm left with 61 degrees for this angle. So now I can finish this off and say sine of 61 over 18 to get that unknown side length. All right, so now I'm going to cross multiply in order to solve this. 18 sine 55 equals C sine 61, and divide both sides by sine 61, like I've done in the previous ones but didn't write down. C is equal to 18 sine of 55 over sine of 61. So we'll type that in the calculator there. $18 sine of 55 divided by sine of 61. And I get 16.85, about 16.9. We'll check that that makes sense. For the side of C, 16.9 opposite a smaller angle, and a bigger side opposite a side angle that's bigger. And yes, we do have that. So the length of the unknown side is about 16.9. Now the only difference for the last example is it says solve the triangle. Remember from basic trig, solving the triangle means to find all the unlabeled or unknown sides and angles. So triangle ABC has A equal to 8, the side opposite angle A. The measure of angle B is 120. This is an obtuse triangle. My drawing is not to scale, but that's okay. We can still use the image to relate things and solve it. And the measure of angle A is 25 degrees. So right away, since these two angles add up to 145 degrees, we can find the measure of the third angle by subtracting and get 35 degrees. So that's one step in solving it. We don't have to use law of sines at every step. And so I need to find 2 unknown sides. I need to find C and I need to find B. So I'll set up 2 sines. The sine of 25 over 8, that's the one opposite paired angle and side that we know, will equal the sine of 35 over C, angle and opposite side. And I'm also going to solve the sine of 25 over 8 equals the sine of 120 over B, so that I'll have 2 law of sines to solve for 2 unknown sides. If I cross multiply and then divide by sine of 25, I get that C is 8 sine of 35 divided by 25. Oops, do it again. 8 sine 35 divided by 25. So you can see here that I did 8 sine of 35. I divided it by 25, or sine of 25, and I got it about 10.9. So C is about 10.9. And then for the other one, I'm going to do 8 sine of 120 and divide it by sine of 25. So 8 sine 120 divided by sine of 25. I get about 16.4. So B is approximately 16.4. C is approximately 10.9. Let's go back and check the reasonableness of that. Largest side of the triangle, opposite largest angle, smallest angle and smallest side opposite, and the medium opposite the medium. And there we go. Now, yesterday in class, after we learned the law of sines, I gave you all a simple ticket out where you were to label which triangles could be solved by the law of sines and which could not. We did not choose A because it's angle, 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 which is not a triangle congruence criteria. It is only similarity criteria. Therefore, you can't solve for anything because the lengths of the sides could be infinitely many correct possibilities. On B, it is side, angle, side. This is a unique triangle. Its sides and angles are predetermined. However, you cannot use law of sines because you don't have an angle opposite either one of these known sides with which to work. So it is solvable, it's just we can't use law of sines, but not law of sines, which is why we're going to be deriving the law of cosines shortly. This one, angle, angle, side, can be solved using the law of sines. You could actually, or at least a first step could be, if you have 50 and an opposite side, you could take this 60 and do this opposite side, or you could find the third angle of the triangle and solve for that opposite side. D is a side, side, side situation. Okay, you know all three sides, but you would need at least one angle to set up and do law of sines. So this one also is solvable, but not with law of sines. Of these two, we're going to find in side, angle, side, or side, 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 we're going to need law of cosines. E, angle, opposite side, no angle, opposite side. I could solve for this angle right here using the law of sines. This is an angle, side, side situation, side, side, angle, which we later learned was not, or earlier learned was not a congruence criteria because there is more than one possible triangle. This is going to lead to a discussion of the ambiguous case, which we're going to come back to in just another day or so. And F, this is an angle, side, angle situation, can be solved using the law of sines, and you do get unique solutions. You have this angle is 60. We did an example like that a minute ago. So 60 over 2, sine of 60 over 2, sine of 70 over x, sine of 50 over y. You could solve for both of those. Which means if we're going to answer this last question that says, when can law of sines be used and when can it not? Answer in terms of congruence correspondence. It can be used definitively in angle, side, angle, and angle, angle, side situations. But it's ambiguous. You might get more than one triangle for side, side, angle situations or angle, side, side situations. We're going to learn about that later. It can not be used for SAS or SSS situations. We will need law of cosines, or for you now, we will need something else because we have not derived that yet. And angle, 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 not solvable due to similarity. That's the end of this lesson on simple law of sine.